continue talking through the recognition of polynomial functions, and we'll go through a few more tendencies on how to hopefully be able to look at a graph of a function and be able to tell a number of different things about the equation of that function based just on what we see. Okay? And so the first thing we want to do is talk about how you can identify a polynomial from a graph. Okay? There's three things that you need to be aware of regarding a polynomial. And again, it's not just a function, but a polynomial. Okay? And so based on identifying a graph as a polynomial, you need to look at the following three things. First, you need to see, is the domain all real numbers? Okay. In order for a graph of a polynomial or a graph to demonstrate it's a polynomial, the graph has to be, any real number has to be a valid input for that function. Okay. The second condition that you have to, that has to be met is that the graph has to involve smooth curves. What that means is there's no sharp changes in direction, okay, or corners in the graph. And then the final thing to recognize and identify in order for a graph to be a polynomial is it needs to be continuous. Okay, what that means is there's no breaks in the graph. Okay, so if all three of these conditions are met, then you should be able to recognize the graph as a polynomial. Okay, so if we look, and we'll just go across the top here from left to right. So would this be a polynomial? Yeah, all real numbers, the domain, it has the smooth turns on it, and it's continuous, no breaks. So this is a polynomial. What about this? No, it's an absolute value, right? There's a sharp corner or a sharp change in the direction of the graph, so that is not a polynomial. What about this? This has a limited domain, right? And in fact, it's not even a function. Okay, so this one is not a polynomial. What about this? Again, it's not a function. It doesn't pass the vertical line test. It's also not continuous, or in this case, there's a break between here. The domain does not involve all real numbers, and so that one's not a polynomial. What about this? Yes, it fits all three of those criteria, so that is a polynomial. What about this graph? Again, it has this break in the graph, so that one is not a polynomial. And then finally here we see, again, breaks in the graph, not a polynomial.